Hi everyone, and welcome back to the Offsite channel. This is podcast number 2. And in this edition, we welcome Keith Cotter from HSB CAD, who will be delivering a presentation on Design for Manufacturing and Assembly, or DfMA for short. Afterwards, Chris and I have a brief closeout discussion. So catch us on the other side of the presentation if you want to hear us going over things. So without further ado, let's hear from Keith.
Hi, I'm Keith Cotter and I'm the Global Business Development and Marketing Manager of HSB CAD. Firstly, I'd like to thank Greg Watson and Christopher Gould for allowing us at HSB CAD to present on the Offsite channel on the topic of design for manufacture and assembly in the world of offsite construction. I guess in the digital era, there are many software solutions today covering what they perceive as the area of design for manufacture and assembly, often known as DfMA. But many focus really on that one area that they think covers it all, and that is the design space, and probably forget to give a really due diligence to that manufacturing and assembly area. DfMA, as we probably all agree, is really a revolutionary movement in the world of construction because it aspires to change the way we build and grow out. And today we probably see some of the greatest projects that exist purely in this space. Today, I'd like to show you how we at HSB CAD demystify this whole DfMA story, and by providing the best-in-class software solutions to clients very like you, who are today reaping the benefits of this whole holistic approach that we've taken with our solutions. So let's jump in, let's take a look, and hopefully you'll enjoy. So kicking off in the DfMA process, what we first met with is the design stage, and here the architect would do the handover to the manufacturing designer, who would then prepare the fabrication documents for the factory, and from there the factory is then creating the CNC files, and these files are then loaded onto a manufacturing line, produced, put on a truck, and then finally sent to the assembly site for construction. And when we look at the 3 stages of DfMA, we have identify ourselves with design, manufacture and assembly. And I suppose what really goes on in the design stage is all that detailing, like adding milling lines, nail lines, metal part, all the connections, and all that real detailing, because if we don't get that information right at the design stage, then your manufacture and assembly become very problematic. And that's where the expense of the whole offsite begins to show. And so by getting the efforts of your design correct will allow us to have a more sustainable, accurate output in our manufacture and assembly. At the manufacture stage, it's all then about how we route the information through the factory in the most optimized way, and using some digital screens be able to display on each of the stations only the information that's relevant to that station, and be able to get the correct data at the right moment at that station. And finally, we would then have the assembly stage, where traditionally this has always been a paper-based environment where many of the site teams are used to holding paper. This now has the opportunity to become digital, so that they can really see in their digital model on site where certain panels need to be placed. They can also see how a truck is stacked. They can also use QR coding and even do issue tracking management, which is all connected centrally back to the main office. In HSP-CAD, we have a solution on all of these process steps in the DfMA space. In design, we have HSP Design for Revit, completely integrated in Revit, and also HSP Design for AutoCAD, likewise integrated into AutoCAD. In the manufacturing space, there's HSP Make, and essentially this allows us to get the right data at the right time and the right place in the factory. And this will also allow you to link to your in-house ERP systems also. And finally, assembly, where we can have our HSP share environment. And this will allow us to streamline and be able to digitize the assembly process so that your site teams will be able to have an online platform as well. But before we jump into any of those, we should really grasp where does DfMA bring us and what type of projects it brings. And really in the DfMA space, it does have multiple diverse disciplines of construction, and so much that it enables all of these forms when we use DfMA. Take for example the image in the top left. This is the refuge in the Mont Blanc, and what's interesting about this particular project is obviously being in an area where it's not easily accessible on a mountain. A lot of the components here were transported by helicopter. So you can imagine that the precision and the accuracy in manufacturing and getting the information right on the first go was going to be a key element for this particular project. Take the image in the bottom left corner, the Kanazawa train station in Japan. You can see is meeting the demands probably of the Glulam structures and how you really have to have intricate connections to make that happen. And yes, of course, these are iconic projects and are probably projects you don't really see every day. Of course, we do have the mass market, and many of the organizations have broken through into this market and they really are delivering results. For example, you have Boclock, IKEA, you'll have Integra in California, who are really driving forward in terms of offsite. You have Kingspan, but we should also not forget that some of the past innovations that have also attempted to do this mass market may not have come completely up trump, but they have driven that revolution forward, and they should be recognized in terms of their input to DfMA. One such company, Integra in California, are really driving forward this fully integrated offsite construction, and they're really adopting the full holistic view of having design, manufacture and assembly completely embedded into their business. An example in the top right corner, you'll see a number of screens, is an example of where HSP Make is currently being used as a digital platform in their factory. Contrary to the mass market, there is also a steadily growing market, and that's the CLT market. And this certainly is paving its way in offsite, and many of the manufacturers are leading this charge in DfMA. Many of those, KLH, Stora Enso, Sodra, Haslacker, are all of the main manufacturers in Europe today. Some of the projects that they meet are very much some of the high rises that we see today and some of the great projects purely born out of CLT. In fact, I think it's probably good to mention at this stage that if you take yourself to our website and to the section on resources, you can find some very interesting white papers on a number of topics, and one of these topics talks about the 5 tallest buildings that have been done using mass timber in this case. Of course, we can't forget modular construction. Modular construction is also one of the disciplines that's really challenging the DfMA process, probably the discipline that requires the most precision and most accuracy in terms of getting it right in terms of digitization. It's important that you have a digital software solution that can meet all of these disciplines, that can be really future-proofing your solution, future-proofing your business. So it's essential you do have the correct software choice. Many of the solutions in DfMA are available today. HSBCAD is one of those, and have many of these solutions available in all aspects of design, manufacture and assembly. And if we were to focus in on our design platform for AutoCAD today, you'll see that we do have a number of tool sets that meet many of those disciplines in terms of timber, StickFrame, CLT, SIP, log, and all of these are possible in our AutoCAD platform. To give you an example of how one such company, Rubiner, are using our design platform, this is the Pyramid Gould in Austria, which is a beautiful building of twisted glulam beams with metal components and can be seen from far and wide in Austria. And this company Rubiner, you can see their process of being able to create the glulam beams within the factory using equipment from Hundegger to be able to cut and make precision accuracy for the metal components so that they can really fit between the glulam beam and hence result in building up the entire structure that we see here in the image. Contrary to that, staying with AutoCAD, what we currently have is also our timber solution, and fundamentally our timber solution works on the following principle, in that principally we have the ability to be able to draw two beams, and these beams are our own objects, so these are not solid objects. And the whole concept is that once we place a metal component, as you can see shown thus here, that metal component automatically cuts the notches and the drills and makes that beam immediately ready for CNC processing. So you can now send that to any crosscut or CNC capable machine in this case. By changing the width and height of a beam, it will automatically adapt the metal component so that you will get the correct metal component based on the size of the actual beam itself. As I start to adjust the beam, you'll notice that equivalently the entire beam structure gets updated and shows you the ability that it can be updated on construction of the metal part. Similarly, we also have a StickFrame solution in AutoCAD, and principally this is a 3D building drawing in AutoCAD. It's not 2D, which a lot of people think that AutoCAD is only capable of doing. This will allow us to create from an architectural drawing and be able to add all our detail libraries and be able to generate completely a full StickFrame model with all the various connections, sheet connections, and then hence from that automatically produce fabrication drawing, which will automatically be sent to the factory if required. If you're doing more detailed closed panel systems, for example, you may want to add some electrical components like shown here, and it's completely parametric so that if I do change any of these components, the entire model gets updated in the 3D model in this case. Moving on into the Revit space now, and you can see that we also have tool sets in the Revit space, and very similar to the AutoCAD, once more again we have the ability to be able to create metal components, beam, and as you create those metal components, it too creates the beams with all the cuts and slots inside here, and all of these particular slots are all CNC capable. So yes, you can create CNC files directly from the Revit space as well. We also have the StickFrame solution, and very similar to what you saw in the AutoCAD space, you now have that ability to be able to create your own library of component parts in here. So at the moment we're now seeing how we would create a typical wall and how we might detail, we say in this case, the bottom of the wall, and it's now adding beams here, and it's all real time, so I can really see the changes happening in my detail to make sure that everything is correct. Precision is important here, so we'll probably want to be able to stretch things, move things back accurately, and tolerances, for example, might be key here. So how often do you want to have that 1-2 millimeter step back from the edge of the panel because of tolerance in this case? So this is a fully integrated detailed system where it will allow you graphically to define all your connection detail by yourself, and this can be done for all T-junctions, corner connections, for around openings, and to be able to create those details as you would desire. And then finally you will come to the stage where you'll want to frame, completely integrated within Revit. We use all the tool sets and commands of Revit, so we work with native Revit object. And here what we have is a beam, and we're now going to add a pocket into the wall so that it knows that this particular beam requires so many studs under in order to get the support for the beam in itself here. In terms of checking the model, validations are also a critically important thing. And what the validation will allow you to do, it will allow you to check the particular model and be able to see that the model is accurate and ready for manufacturing in terms of validations. Shop drawings are also automated, and we can produce a full set of shop drawings based on the output in our StickFrame model. And consequently, we can also create direct CNC files to all CNC machines. Contrary to Revit, we also have partners. So for example, Rotoblast, one of the bigger tooling, fastening type customers of ours, have put in their complete library inside in Revit today. And what we can do is, what's very important, what I'm about to explain next, is one can in the Revit space create their own family metal part. But the issue that they will have is upon placing that metal part, if there's any editing of the beam, such as moving the beam afterward, the metal plate is not attached to the beam. And we'll see that in an example here where we have two beams drawn. They've created a family metal part by themselves, which is very, very normal for any Revit user. They put it in position on the beam. And once we move that particular beam away, you'll then see that the metal plate remains in this case. However, using our design software, we have a smart tool called HSB Flex, very similar to family, only that we have now what's called a coded family extension, which will allow us to make the tool clever. And by this I mean that similarly we would add a metal plate between two beams, but this would automatically cut the actual beam in terms of tooling. And you can also see that the tool is also visible here. And the most important thing here is that if I go then to move or copy that, the beam automatically moves in this case. So that's HSB Flex, an extremely powerful function that we have in all our tools, including stick framing. So if you have a pocket, a point load, a lifting hole in stick framing, all of these are using the Flex technology. In terms of manufacture, we have a number of tool sets where we have the client screens in the factory, where we have nesting. If you had ERP integration, you'll be looking at the BOM link. Multi-walling will allow you to create and optimize your complete wall and give you that ability to optimize the wall into one long length and then break it up in the factory afterwards. But again, another example of how Make is used in an organization. This would be typically a project. This runs both in AutoCAD and Revit, where you will be able to create a project and issue all the CNC files for the Make system to it. And as a production manager, this would be their tool of choice that they would use. And this would allow them to be able to, one, open up the project once it has been issued by the design team. They can already start to check to make sure everything is looking okay in the initial model. And once that model is okayed by the production manager, they can then create the files. This is an overview of the entire factory process and be able to see what happens at each station. And that representation would be typical of a factory, something similar to this, where you would be able to see what would be bottlenecking in a factory, what would be flowing well. And typically you would be met with machines in a factory in an automated environment, bearing in mind it can also be used in a manual station, but at each station, whether manual or automated, you would be presented with screens like this that would only show the information that in this case is the information required at that station and nothing else. So you can really configure all of these client screens and get the real-time data appearing on those stations just in time manufacturing. And finally we have our assembly, and here we have a number of tool sets where you can have logistic management, which will allow you to control your placement of your various packages in a factory environment, or the stacking solution that will allow you to create the truck loading in your factory. And an example of this would be that you could log into a cloud platform which will allow you to access all your files, and any of these files can be accessed, for example, in a production environment. It could be a production manager that would want to be able to access his factory and see how it's performing while not in the factory environment. On terms of the assembly team, it could be the team wanting to view the digital model while on site, be able to query it, be able to turn on and off aspects of the building, measure components. How often have we been in a situation where the fabrication drawings are not exactly dimensioned to what the site team require, and hence they will be able to adapt and be able to measure this here on this model. They could also do issue management, which will allow them to record any issues that they may see on site and report this back centrally on here as well. So we've done a full circle around and we come to the stage of the final steps of DfMA. I hope you have got an appreciation for how we at HSB CAD can help organizations like yours to maybe adopt that principle of design for manufacture and assembly. One such company here in Tekra are surely one of those, based in California, that are really adopting the whole design, manufacture and assembly, and today are producing some of the state-of-the-art homes in the American region. So once again, I want to thank you for listening, and I hope that you found it interesting. And if you do have any questions regarding this presentation, here are my details, and feel free to reach out to me and I'll be more than happy to talk with you. Thank you again.
Hi everyone and welcome back. I hope you enjoyed the presentation by Keith, and I want to thank Keith and HSB CAD for providing that presentation. I thought it was very, very informative and provided a great deal of value on the subject of DfMA. And what I would take from that, Chris, and both Keith and Franco noted in separate previous podcasts and this one, is that the accuracy of the design is key in getting the manufacturing and assembly aspects correct as well. And if that's not the case, then it can lead to severe cost implications in both manufacturing and assembly. So more and more accuracy is key in producing designs, because it has knock-on effects further downstream in the process. I don't know if you agree with that.
Yeah, as always, I mean, the design is the critical element and getting the proper product in the field. And I think we saw with that video with Keith, you know, the fact that it's pre-cutting for the metal connectors, you know, becomes a critical component for loading as well. You know, to make sure that we have the proper application of wind and vertical transfer.
Yeah, I also thought, moving on to the manufacturing piece, the data that they have at these framing stations only has information pertinent to that specific framing station. So they don't have information there that's not relevant to what they're doing. So I guess that would kind of reduce the errors that were possible at that point, because they're not overloaded with information that they're not concerned themselves with. And also, you know, they aren't paper copies; they are digital. So we'll move into the digitalization of the manufacturing process as well. I thought that was quite interesting as well, Chris, and if you agree.
Yeah, indeed.
Yeah, and then moving on to the site assembly aspect, and obviously we would be used to sending out paper plans, paper sets, and we would still produce those, send them out in a drawn pack. But additionally to that, they have the ability, and other providers also have the ability, not just HSBCAD, but others do have the ability to provide a 3D model and on a platform that they can share with the people on site. So they can, if they have any queries, they can interrogate that first, and then if they have any discrepancies or issues, then feed that back within that system back to the design office for query to have anything clarified. So again, moving to the digitalization of assembly as well. So I found the presentation really informative. Again, want to place thanks to Keith and HSBCAD for providing that. So in the coming months, we will have some other software providers giving us input as well. But again, thanks to Keith and HSBCAD for providing the first one, which I find was great value. So
yeah, you mentioned the 3D modeling aspect. I think that's going to be critical as we unleash new types of products into the field, into the industry, because somebody's going to have to assemble it, and therefore somebody's going to have to know what it's supposed to look like. You know, the whole training aspect, and with these more complicated ones, like some of the ones that we just saw, it's very important that we have some sort of tool to allow them proper manufacturing to erection procedures.
So moving on to the next podcast, we have, I would say, I wouldn't want to confirm it just yet, but a well-known personality within the industry has agreed to come on. So I'll not say much more at this point in time until it's confirmed up, but I'm looking forward to the next one already. So with that being said, I want to thank everyone for tuning in. Hope you found value in the content, and thank you very much.